Hello everyone. Today I will discuss about the difference between 4-stroke IC engine and 2-stroke IC engine. So actually in this figure you can see this is the suction stroke and this is compression stroke. Okay, and this is the power stroke or expansion stroke, and last is the exhaust stroke in this figure. Okay, so first I would like to describe the suction stroke. Okay, so now you can see here, you can see this is the cylinder, this one. Okay, this is piston in red color, this is inlet valve, this is exhaust valve, this is a spark plug in case of SI engine. Okay, and this is the piston ring, and this is a lubricating ring, this is connecting rod, crank, and this is crankshaft, and this is the casing. Okay, so these are the parts of this engine, and this is the top dead center and this is bottom dead center. So in the first case you can see this is actually the suction stroke. So here this piston is moving vertically downward from TDC to BDC, and the inlet valve is open. Okay, so this will suck the air fuel mixture in this combustion chamber. So in the top location of this piston, suction process is taking place. Okay, so this piston is moving TDC to BDC. So this is actually the uh, suction stroke, and this is the stroke length here to here. Okay, so this will be stroke length L. Okay, so during this suction process, this connecting rod and crankshaft will rotate this, sorry, crank and connecting rod will rotate this crankshaft. Okay, so this rotation will be equal to 180 degree. Okay, so during this suction process, this shaft will rotated 180 degree. Okay, so now we will talk about the compression process. So when this piston is at the BDC, okay, at the BDC, and it is moving towards the TDC. Okay, so this is moving BDC to TDC, and the inlet and outlet both valves are closed. Okay, so here you can see this volume is decreasing. Okay, so due to decrease of this volume, pressure will be increased. Okay, so here this is going here to here. Okay, here to here, this is actually the compression process. Okay, so during the compression, the volume will be decreased and pressure will be increased, so the air fuel mixture will be compressed. Okay, in this compression process. So now we can see this third figure. So this is actually the power stroke or expansion stroke. So during this stroke, this inlet valve and outlet valve, both valves are closed. Okay, and this piston is moving TDC to BDC. Okay, so here you can see in the compression, this piston was moving from BDC to TDC. Okay, and in suction it was means moving TDC to BDC. Okay, so this movement of this piston TDC to BDC was equal to 180 degree of crank angle. Similarly, this is moving BDC to TDC, means it is traveling BDC to TDC, and it is rotating this crankshaft 180 degree again. So total angle rotated by the crankshaft is equal to 180 plus 180, means this total rotation of crankshaft is equal to 360 degree, means one revolution. So in these two strokes, suction and compression, one revolution of the crankshaft is completed. Okay, so in the third means in expansion process, again this piston is moving TDC to BDC, means this reciprocating motion is converting this reciprocating motion is converted on the crankshaft. So this will be again 180 degree. Okay, so total angle will be 540 degree till the expansion process. So during this expansion process, inlet and outlet both valves are closed and the air fuel mixture is fully compressed, and we are providing the sparking from the spark plug. So combustion will take place uh, combustion will take place in this combustion chamber, and due to the combustion of fuel, thrust will be provided by the burnt gases. So this piston will move vertically downward TDC to BDC. Okay, so this is called the power stroke. Okay, again the burnt gases will be thrown out from this combustion chamber. So this piston again will move BDC to TDC. So the burnt gases are thrown out via this outlet valve. So in exhaust stroke, outlet valve will be opened and the inlet will be closed, and there will be, so this is the exhaust uh, process and stroke. Okay, so here you can see the total angle total angle of rotation. This crankshaft is equal to 180 plus 180 plus 180 plus 180 means 720, means there are two revolutions of this crankshaft during the suction, compression, expansion and exhaust process. So you can imagine that in these four strokes, only in one stroke power is produced. Okay, in one stroke power is produced. Okay, so remaining these three strokes are completing by consuming energy produced in the power stroke. Okay, so this was the functioning of this four stroke engine. Now we will talk about the functioning of the two stroke engine. Okay, so here you can see in this figure, so this is actually two stroke engine. Okay, suppose this is SI engine, so spark plug is there. Okay, so this is the cylinder. Okay, this red in red color, this is piston, this is connecting rod, this is crank and this is crankshaft, this is casing. Okay, and this is inlet, air fuel inlet, and this is exhaust port, this is transfer port. So in this transfer port, air fuel mixture compressed in the bottom location can be transferred here to in this combustion chamber. Okay, so this is the functioning of the two stroke engine, and this is the piston ring and this is a lubricating ring. So these are the parts of this engine, and one part you can see deflector. So deflector is provided here. So the functioning of deflector is to travel the fresh charge in the upward direction. So this will take some time to reach to the exhaust. So I will tell you later about it. So actually this piston is moving BDC to TDC. Okay, when this piston will move BDC to TDC, so in the bottom location volume will be increased, means suction kind of things will be there. Okay, when this piston will move here to here, means here. Okay, this will close this port and this port. Okay, so the air fuel mixture enclosed in this combustion chamber will be compressed. Okay, so compression process is taking place in the top location of this piston, and expansion is taking place in the lower location of this piston. That's why this expansion of volume below beneath of this piston will suck the air fuel mixture. So air fuel mixture will be filled in this casing. Okay, so when this piston will move at the TDC, we will provide the sparking. Okay, so combustion will be taking place due to the sparking. So due to the combustion of fuel, the burnt gases will push this piston in the downward direction. So this piston will move TDC to BTC. Okay, so this will be actually power stroke. Okay, so this piston is moving TDC to BTC. Okay, so initially it was supposed on this location at TDC, and during this process this piston is reached here. Okay, here. So actually when this piston will reach in this location, this valve will be this transfer port will be open. Okay, so the air fuel mixture compressed in this bottom location will be transferred into the combustion chamber. Okay, so here after the combustion of fuel, this piston will be reached here. So fresh charge will be entered here, and this burnt gases will be exhausted via this exhaust port. Okay, so here you can see power stroke and fuel transfer is taking place in same motion of this piston. Okay, so here you can see the fresh charges entering, and burnt gases are leaving this combustion chamber. So some part of this fuel will be transferred via this exhaust port. So to reduce this loss, we will provide this deflector, and this deflector will increase the path of fresh charge. So this will reduce the loss of fresh charge via the exhaust. Okay, so here you can see in the 100-degree crank rotation. Okay, means piston is moving BDC to TDC, means crank is rotated only 100-degree angle, and 2 strokes are completed. Again in 100-degree rotation of this crank, 2 strokes are completed. Okay, so here you can see in 180 plus 180 means 360 degree, means one revolution. Okay, so in one revolution of this crank shaft, one power stroke is there. Okay, so here in one revolution of crankshaft, one power stroke will be there, but in case of 4-stroke engine, in 2 revolutions of crankshaft, one power stroke will be there. So this was the difference between 4-stroke engine and 2-stroke IC engine. Thanks for watching this video. All the best.